are going to discuss about the SAR of H2 receptor antagonist. Usually, histamines will act on mainly two receptors. One is H1 receptor, another one is H2 receptors. See, this H1 receptor antagonists are used in the treatment of allergic conditions, whereas H2 receptor antagonists, they are used for the ulcerative treatments. The first drug that has been used to develop as a H2 receptor antagonist is guanine histamine. This is the first drug to develop H2 receptor antagonist, and this is the structure of guanine histamine. Here we will find that imidazole structure. In this one ethyl and guanidine will be attached here. So normally histamine will be having this CH2, NH2. So this is the first antagonist that has been developed as a H2 receptor antagonist. So the length of the carbon chain, if it is increased to give the H2 receptor antagonist, that will provide a very good antagonistic activity. So this is the one example, that is burimamide. Here the length of that compound has been increased. Here we will find that one. Here it is a ethyl group is present, CH2. But here CH2 4 times it is present, then that guanidine will be present, that NH, C double bond NH, and CH3 will be present. So if you are increasing the carbon length, carbon chain length, that will also produce the very good H2 receptor antagonist. If you are substituting with the one methyl group, that is if you are replacing the methyl group by a sulfur group in the fifth position of the imidazole ring, that will also give the more potent compound. Here we will find the example of that one. So if you are replacing the methyl group with the sulfur, that will also give a potent compound. Here the compound we will find that one, that is metamine. So this is the methyl imidazole derivative. In this one we are attaching CH2, CH2, NH, C double bond S, NH, CH3. That is a metamine. That is also having very good potent H2 receptor antagonist. And later they have given further modification has been made to develop the newer H2 receptor antagonist. So first they have started like this, and later they have made so many modifications to give the latest drug. So we might have heard about the compound Cimetidine, Ranitidine, like this. So Cimetidine, which has lesser side effect when compared to other H2 receptor antagonists, this is the structure of Cimetidine that is used as a H2 receptor antagonist, which is having the lesser side effect. Here what is the modification they have made? Instead of C double bond S, they are replacing with the C double bond N CN. So C double bond S will be replaced by the C double bond N CN in order to reduce the side effects. So this is the example, that is Cimetidine. In imidazole structure they have replaced CH2, CH2, NH, C double bond N, Cn. Whereas in that one, C double bond S will be present. Here C double bond N, Cn will be present. Okay, then NH, CH. This is the structure of Cimetidine. So the basic nucleus is imidazole. So we have seen so many drugs. All the drugs are having the basic nucleus imidazole. If you find the guanine histamine, burimamide, metamine, as well as Cimetidine, they are all are having the imidazole structure. Whereas if you are replacing the imidazole with the thiazole, that will also give good potent compound. So to give the Famotidine, so this is the structure of Famotidine. Here we are replacing the imidazole, not only imidazole, we are making some other substitutions also. Here we will find in fourth position the substitution will be the CH2, CH2, C double bond N, SO2 NH2 group will be there, and in addition to that guanidine group will be present here. This is the structure of Famotidine. Similar to the Cimetidine, Famotidine also good H2 receptor antagonist. Then the next one is the replacement of imidazole to furan. So we are replacing imidazole with the thiazole. Not only thiazole, we can replace with the furan. That will also give the compound which will act as a good potent H2 receptor antagonist. So this is the Ranitidine, which is having the structure. In the second position, it is having the CH2 and CH3 twice, and here we are attaching the CH2S, CH2, CH2, NH, C11CHNO2, NH, CH3 group is present. So what is the main use of this? We might I hope you could understand what is the SAR of this one. What is the use of this H2 receptor antagonist? It blocks the production of hydrochloric acid. So mainly they are used for the treatment of ulcerative colitis. So it is used in the treatment of peptic ulcer, Zollinger-Ellison syndrome, and also used to treat non-ulcerative dyspepsia. I hope you could understand what is the SAR and what is the use of this H2 receptor antagonist. Thank you.